In the previous lecture, we finished chapter 1, which was about domain, range, and graph of multivariable functions. And now we have chapter 2, which is about partial derivatives. In the first section here, we have first order partial derivatives. We are going to take the first partial derivatives for the functions here. We say like this. See, the partial derivative f sub x of f of xy with respect to x is obtained by holding y constant. That means we treat with y as constant. And differentiation with respect to x, we are going to take the derivative with respect to x for the function and treat with y as constant. And the partial derivative f sub y for xy, for f of xy, with respect to y, in this case, we're going to treat with x as constant. And then we differentiate the function with respect to y. Here, these are the definitions of partial derivatives. We say f sub x of xy is equal to the limit of delta x approach to 0 for f of x plus delta x and y minus f of xy dividing by delta x. This is for f sub x. And for f sub y is the limit of delta x approach to 0 for f of x and y plus delta y. Here, in this case, when we take the derivative with respect to x, we have x plus delta x and y. But when we take the partial derivative with respect to y, we have x and y plus delta y minus f of xy dividing by delta y. These are the definitions of taking partial derivative of a function with respect to x and y. And here we have these notations for partial derivatives. When we say f sub x, it means partial f by partial x. This means partial f by partial x. And also when we say f sub y, it means partial f by partial y. And finding the partial derivatives at the point x naught, y naught, we first take the partial derivative. For example, if we want to find f sub x at 0 at x naught and y naught, we should first take the partial derivative with respect to x and then plug in this point into the results. And we also can write down like this, okay, or like this, or like this, okay. These are the notations of f sub x at a point, and even for f sub y at a point, it's the same. Here we have these two examples. In the first one, we have f of xy equals 2x squared minus 3x squared y plus y squared minus x plus y plus 1. We are asked to find f sub x at 0 and 1, and also f sub y at 0 and 1 for both of these two functions. Let's do it for the first one. As we said before, when we take the partial derivative of the function with respect to x, we treat with y as constant. And for y, we treat with the x as a constant. Let's first answer the first one. So the first one, this is the function. For this function, we are going to take f sub x and f sub y. And then we plug these 2 points, this point into the partial derivatives. We say f sub x of xy, it equals, we are going to take the derivative, the partial derivative of the function with respect to x. In this case, we treat with y as constant. That means derivative of y, if you have y alone in a term, we say its derivative is 0. Okay. Look, we have 2x squared. As we take the partial derivative with respect to x, so it becomes 4x. Is it? And for 3x squared y, here in this case, in this term, we have 3y, this constant, and we have x squared. As the same as to say ax squared. Okay, because 3 and y are both constants as we take the derivative with respect to x. So it equals 2ax. So here we have 3y. It becomes 6yx. Is it? So this is the derivative of the second term. We get minus 6xy. Y is a constant. And here we have y squared. We have no x in this term. That means its derivative is 0. If in the case we take the partial derivative with respect to x, if any term has no 0, we say its partial derivative is 0. Okay? Sorry, if any term has no x, we say its partial derivative is 0. So here the partial derivative of y squared is 0. How about partial derivative of minus x? We just take derivative of x, we get minus 1. So the derivative of y with respect to x is 0. This is also 0. So this is 0, this is 0, and this is 0. These three terms are 0. I mean the partial derivatives, the derivatives with respect to x are 0. This is f sub x. How about f sub x at 0 and 1? We say f sub x at 0 and 1 equals what? We just replace x by 0 and y by 1. Okay, we get 4 times 0 minus 6 times 0 times 1 minus 1. It equals minus 1. So this is f sub x at the given point. So for f sub y of xy equals what? We are going to take the partial derivative of the function with respect to y. Okay, here we are going to treat with x as constant. Treat x as a constant. This term is 0. This term becomes 0 because we have no y in that term. We're going to take the derivative with respect to y. As you have no y in that term, so its derivative is 0. So this becomes 0. We don't write down anything for that term. And for this one, we have minus 3x squared. This is a constant times y. Let's say it's ay. How about the derivative of ay? It's only a, is it? So here, the second term becomes minus 3x squared. And y squared, its derivative with respect to y is 2y. The derivative of this term, minus x, with respect to y, since you have no y in that term, its derivative is 0. And derivative of y is 1. Derivative of 1 is 0. Okay? Is it clear? Okay, so this is f sub y. Then f sub y at the given point is, we replace each x by 0 and y by 1. So we get 0 plus 2 plus 1, which is 3. That means f sub y at 0 and 1 is 3. Now for the second equation, for the second example, we have f of xy equals sine pi x plus 2y dividing by 1 plus x. Here we should find f sub x and f sub y at 0 and 1. Our function is f of xy is sine pi x plus 2y over 1 plus x. First, let's find f sub y. It's easier. And then we will find f sub x. Yes. This one. Look, here in this case, we are going to take the derivative with respect to y. And the term is minus 3x squared y. If we take the derivative for this term with respect to y, this is a constant. We just treat with this as a constant. So let's say it's ay. How about the derivative of ay? It is only a, is it? So what's a? A is minus 3x squared. ليه أركاتك داتا شابه نسبة y ورقين x كونستانت. لا كونستانت قاعد يعني داتا شابه x ورناقل. والله كاتك بنسبة x وداتا شابه ورقين أو كاتا y كونستانت. Here we are going to find the partial derivative for this function with respect to y and with respect to x. Taking the partial derivative with respect to y is easier. We are going to take that first and then taking the partial derivative with respect to x later. F sub y of xy equals what? Here, the denominator is constant because we have no y in the denominator. We have no y in the denominator. Okay? And you have sine pi x plus 2y. If we take the partial derivative for the function with respect to y, we get the derivative of sine is cosine. It's cosine of what? Of the angle pi x plus 2y over 1 plus x. This is a constant. That's why just write down the same. Because here we take the partial derivative with respect to y. So we treat with all x terms and constants and numbers, I mean, as constants. This is the derivative times derivative of the angle. What's the angle? The angle is pi x plus 2y. If you find the partial derivative of this function with respect to y, this becomes 0. Is it? Since pi is constant and also x is constant as we take the derivative with respect to y. So the partial derivative, so the derivative of 2y is 2. That means the derivative of the angle is only 2. That means this is the derivative of the angle. Because here we have pi x plus 2y. If we take the derivative for the angle with respect to y, we treat with x as constant and you get 0 for the first term, and in the second term we get 2. It equals 2 cos pi x plus 2y dividing by 1 plus x. This is f sub y at xy. So how about f sub y at 0 and 1? We just reversed x by 0 and y by 1. We get f sub y at 0 and 1 equals. We replace x by 0 and y by 1. We get 2 cos pi times 0 plus 2. 2 times 1 is 1. Dividing by 1 plus 0. And we get 2 cos 2 dividing by 1, which is 2 cos 2. This is f sub y at the point 0 and 1. Okay? Is it clear? Then let's find f sub x. For f sub x, let's write down the function because when I move to up, it's not appear. Here, f of xy equals sine pi x plus 2y dividing by 1 plus x. We are going to find the partial derivative for this function with respect to x. So here we treat with y as a constant. F sub x of xy f sub x of xy equals. Here we have x in both numerator and denominator. In the numerator we have x in the angle of sine, and in the denominator we have x term also. We say if we have f dividing, let's say, by g, its derivative is f times, say, g times f prime minus f times g prime dividing by g squared. You are familiar with this rule, okay? This is the division rule of derivative. If you have f over g, if you have the division of two functions, that means if you have x in both numerator and denominator, we going to take the derivative with respect to x, we apply this rule. Even if you have y in both numerator and denominator, when we take the partial derivative with respect to y, we should apply this rule. Okay, so let's apply this rule to the given function. We say f sub x of xy equals, you see, we first write down denominator squared, which is 1 plus x squared. Then denominator times derivative of the numerator. Look, you should write down in the same order. Look, denominator times derivative of the numerator, then minus numerator times derivative of the denominator, all dividing by denominator square. Okay, you should write down in the same order. So this is the denominator square, then denominator times derivative of the numerator. What's denominator here? It's 1 plus x times derivative of the numerator. It's the derivative of sine pi x plus 2y. Derivative of sine is cosine. Cosine pi x plus 2y times derivative of the angle with respect to x. The second term is 0 because we have no x in the second term, because we take the derivative with respect to x. And the first term derivative is only pi. Okay, then minus. This is denominator times derivative of the numerator. Then minus numerator sine pi x plus 2y times derivative of the denominator with respect to x. This term becomes 0 and this term becomes 1, multiplying by 1. So this is the derivative. Now we just try to simplify it. We say f sub x at xy equals, here we get 1 plus x multiplying by, here we have pi times 1 plus x times cosine pi x plus 2y minus sine pi x plus 2y, all dividing by 1 plus x squared. Now we are going to plug in the point, the given point. It says find f sub x at 0 and 1. We just replace each x by 0 and each y by 1 in the last equation. Here we get pi 1 plus 0. We just replace x by 0. Cosine 2, is it? Because here we have 0 plus 2 times 1. Let me write down it. 0, because pi times 0 is 0, plus 2 times 1 minus sine 0 plus 2 times 1, all dividing by 1 squared, okay, 1 plus 0 squared. Now we simplify it. We get f sub x at 0 and 1 equals. Here we get pi cos 2 minus sine 2 dividing by 1, which is pi cos 2 minus sine 2. This is the result. Okay, you can find the values of cosine 2 and sine 2 by using calculators, and then you'll get the result. Okay, this is how to find the partial derivative of function at a point. Okay. Now we have partial derivatives as a slope. We say if we have the tangent plane to the curve C in the plane y equals y has the slope f sub x at x naught and y naught. This x naught and y naught. Okay. To find the slope of the tangent line of a curve in the plane y equals y naught. Look, in this plane. And this plane is parallel to what? This is x and that's z. This is xz plane. Okay. This is xz. Look, it's the same as to have a plane like this here. It's parallel to what? To xz plane. Is it? And we have a plane like this here. It's parallel to what? Parallel to xz plane. It's parallel to this one. Okay. Sorry. لا بيش ناخذ دروس كان دروس هناك دروس هناك لا دروس هناك. It's just to know the direction of the tangent line. Look, the tangent line is parallel to what? Is parallel to xz plane. Let's see. Let's say this is a plane. This is a plane. Okay. Here we have a curve. We have a curve like this. This is parallel to what? To xz plane. Okay. And here we have a tangent line. So the tangent line is also parallel to what? To xz plane. Okay. We say the slope of this tangent line is equal to what? Equal to f sub x at x naught and y naught. Here we have, as I said, we have a curve here. At this point, let's say we have a point here. To find the slope of this tangent line, we say since that's parallel to the z plane, it is f sub x at x naught and y naught. We are going to find the partial derivative of the function with respect to x at the given point. And if we have a plane, at x to be x naught, at a point here, at a point somewhere here, this x-axis, and you have a plane at this point, we say the tangent line of the curve here, it's parallel to what? YZ plane. It's parallel to YZ plane. And the slope of this tangent line equals the slope of the tangent line equals f sub y at x naught y naught. Okay, it's how to find the slope of the tangent line to a surface or to a plane. Look, here we have an example. Compute the slope of the tangent line to the surface for the surface. We are going to find the tangent line for the surface. At this point here, this is x value, that's y value, and this is z value. Okay, and here we have given f of xy. That means after taking the partial derivative, we are going to replace x by 1 and y by -1. That's all. It says compute the slope of the tangent line. When you hear the slope of the tangent line, it means you should need to take partial derivative with either x or y. Okay, we can we can know that it's f sub x or f sub y. How? By the direction of the tangent line. It says the tangent line is parallel to what? To xz plane. Look, that means it's at y0, okay, and it's parallel to what? To xz plane. We said if it's parallel to xz plane, we take f sub x, okay? But if it's parallel to yz plane, f sub x. But here we have f sub x because it says it's parallel to xz plane. So we take, look here, it's the same as this one. This is the same as this one. This is parallel to xz plane. That means we should find f sub x at the given point. The function is given. F of xy is xy cubed plus y cubed is plus x cubed y. We have given this function. This is f of xy equals axy cubed plus x cubed y. How to find the slope of the tangent line? Since that's parallel to xz plane, that means we should take f sub x. We should take f sub x. We are going to find f sub x first. Then we plug in the point. So f sub x for the function equals what? We are going to take the partial derivative for the function with respect to x. For the first term, what we get? What do we get for the first term? Only y cubed. Yeah, because we take the partial derivative with respect to x. So here y cubed is a constant. We just need to take the derivative of x and so on. So you get y cubed. How about the second term? As we just take derivative of x cubed. What's the derivative of x cubed? It's 3x squared. And y is a constant. We just write down the same. We get 3x squared y. This is f sub x.
Did you take the derivative 3 times?
No, only once. We just take the derivative once. Okay. So how about the tangent line, slope of the tangent line at the given point? Here, the given point is 1, -1, and -2. Here, we have f of xy. So we just need the values of x and y. We just need the values of x and y. So xy is 1 and -1. That means we replace x by 1 and y by -1. We say f sub x at 1 and -1 equals. Here, this is f sub x. We get -1 cubed plus 3 times 1 squared times -1. That equals -1 minus 3 and equals -4. This is the slope of the tangent line. This is the slope of the tangent line. So what if we are asked to find the slope of the tangent line in the direction of yz plane? what should we do? We should find f sub y. That means partial derivative with respect to y. Okay, that's only the it's similar to this one. Only we take the derivative with respect to y. Okay, and we plug in the point. That's all. Do you have any question about this? Okay. We now have partial derivative as rate of change. So let's take a break for 5 minutes. Okay. Here we have partial derivative as a rate of change. You say a partial derivative is the rate of change of a multivariable function when we allow only one of the variables to change. Here, we have an example. Point P moves along the intersection of plane. In R3, we have no lines. When we say X to be a point, that means that's a plane. Here it's X to be 2/3. That means here at 2/3, this x-axis, at 2/3, we have a plane like this. Okay, we have a plane down and up, and in these directions also. The slope, we have a point which moves along the intersection of this plane with this sphere. Find the rate of change of z with respect to y. Here, we just find the rate of change with respect to y. At this point, we are going to find the rate of change at this point. That means here, we are going to take the partial derivative of f of xy with respect to y and then plug in these points. Okay? So let's first draw the graph. It's easier to understand the example. To draw the graph, here we have a sphere. This is a sphere. The center is 0, 0, 0, and the radius is 1. So here we say if we have a sphere, okay, this is x-axis, that's y-axis, and that's z-axis. We have a sphere which is like this. This is a sphere. Okay, we have this sphere. The center is 0, 0, 0, and the radius is 1. That means it takes 1 unit from each of the axes, from x-axis, from y, and from z-axis, for both directions, and for positive parts and negative parts. It's a sphere like this. We have at the origin, and its radius is 1. And also we have a plate, a plane. We have a plane at x to be 2/3. 2/3 means 4.66. So let's say it's here. At this point, we have a plane. Let's say we have this plane. Sorry. We have this plane. This plane intersects this sphere at where? At this circle. It goes through the sphere. We have a sphere like this, and you have a plane. Its radius is 1. We have a plane which intersects the sphere at 2/3. That means the intersection of the plane of the plane with the sphere is a circle. أنا topic ما حبيت كان رزق بل لا توبكات شو تخوالو يكتب لنا كان شيء بازنين ونيا يكتب ريني أم كان شو كان رزق كأروات تخوالو بناو توبكاء شيء بازنين. Okay, so the intersection of the plane with the sphere is a circle. That's a circle. And we have given this equation of the plane. For this equation, we must find f of xy from this equation. The equation is x squared plus y squared plus z squared equals 1. How to find f of xy? To find f of xy, we must put z alone in one side and putting all the others to the side. Here we have z squared equals 1 minus x squared minus y squared. Okay, because z is f of xy, we say z equals f of xy, and here z equals the square root of 1 minus x squared minus y squared. This is the equation. This is f of xy. So in these type of questions, the most important thing here is to find f of xy. Okay, then it's given that we should find the rate of change for z with respect to y. That means we must find the derivative of f or z with respect to y at this point, and that's all. Okay, here what we do, we are going to find f sub y of xy equals to what? We are going to take the derivative for this function. So derivative of this function, first let's convert this to exponent. We get 1 minus x squared minus y squared to the power of 1/2. Okay, derivative of this equation or this function, we say it is 1/2. We are going to bring the exponent to front. I'm going to write down the general form of the derivative here. If we have v to the power u to the power, let's say n. When u is a function, we say its derivative is n times u to the power n minus 1 times u prime. Okay, derivative of inside of the inside. Here we use the same. So there is 1/2 of, we are going to write down the bracket the same, 1 minus x squared minus y squared, but we reduce the exponent by 1. It's 1/2. Minus 1 is minus 1/2. Multiplying by derivative of inside with respect to which of the variables? With respect to y. Look, we are going to take the derivative with respect to y. If we take the derivative of this function with respect to y, the first term is a constant, 0. And the second term, in the second term, we have only x, so it's 0 also. So it is minus 2y. Okay? So this f sub xy, let's write down it. We say f sub y of xy equals minus 2y. These two could be cancelled out, so you get only y. Okay, minus y dividing by 1 minus x squared minus y squared to power of 1/2. Since that's negative, when you move it down, it becomes positive. So we can write down it as the root 4. Okay, its exponent is negative. We move it down, it becomes positive. Then we convert to roots. Now, to find the rate of change at this point, what are the variables that we have in the partial derivative? We have only x and y. That means here in the point, we just take x value and y value. We don't need to take z value here. X value is 2/3. Y value is 1/3. We just, sorry, this x and that's y. X value is 2/3. Yeah, that's X value. And 1/3 is Y5. We replace X by 2/3 and Y by 1/3. So we are going to find F sub Y at 2/3 and 1/3. It equals 1/3 negative 1/3 dividing by square root of 1 minus 2/3 squared minus 1/3 squared. It equals minus 1/3 dividing by square root of minus 2/3 squared is 4/9. And 1/3 squared is 1/9. We get 1 minus 4/9 minus 1/9. We're trying to simplify it. 4/9 minus 1/9 is, both are negative. We get 5/9 minus 5/9. We get F sub Y at 2/3 and 1/3 equals minus 1/3 dividing by square root of 1 minus 5/9. Now we try to subtract 5/9 from 1. Okay, fine. We get 4/9. We get it equals minus 1/3 dividing by square root of 4/9. 4/9 in a square root is 2/3. It equals minus 1/3 dividing by 2/3. These two are cancelled out and we get minus 1/2. This is the rate of change. This is the rate of change of the point. Sorry, for Z for the function. This rate of change of the function Z with respect to Y. So if we are asked to find the rate of change of the function with respect to X, we just take the derivative for the function with respect to X, and that's all. Okay, and we do the same steps. So the partial derivatives with one of the variables is the rate of change. At a point, it means the rate of change for the function at the given point. Okay. Here, look, we have this plane which intersects it at this seg. This is the answer. Do you have any question? Okay. Now we have higher order partial derivatives. If you take second, third, and fourth, and so on, partial derivatives of a function, we say the derivative of the first derivative, I mean the partial derivative of the first partial derivative is the second partial derivative. For example, here we have the partial derivative of f sub x with respect to x equals f sub x. Here we take a partial derivative for f sub x, and the result is f sub x. And you could write down as f sub x partial by partial x for partial f by partial x, and also partial squared of f by partial x squared. We can write down them. These all are the same. Okay, this is second partial derivative. Okay, and if you have partial by partial y for f sub x, it equals f sub x and y. Look, here we have f sub x. When you take its partial derivative with y, it becomes f sub x and y. And also, it could be written as partial by partial y of partial f by partial x. And also, we can write down as partial squared of f by partial y partial x. Okay? In this form, you first write down this and then this one. And here, f sub x and y. Okay? So this is the second partial derivative. The first with respect to x and the second with respect to y. And for f sub y, it is taking the partial derivative first with respect to y, then with respect to x. Look, just consider these two forms. In this form, y is the first one and x is the second. And here, y is the first, we take the second first, and x is the second. Okay? In these two forms, we usually use these two forms in taking partial derivatives. Therefore, f sub y, it's a partial square root of f by partial y squared. Here we say if z to be f sub xy, then partial square of f of xy by partial x squared. That means taking two partial derivatives with respect to x. First and second are both with respect to x. It equals f sub xx for f of xy. And also we can say it equals partial square root of z by partial x squared, since z equals f. And also z sub xx. We can write down in these forms. Here you have some examples. It says find f sub xx, f sub xy, f sub yx, f sub yy for these functions. Okay? For this one and also for this one. And then show that for the second one, we should show that f z to be this function, 3z sub yy minus 2z sub xx equals 6z. Okay, we must show that for the second one. Here we have the first function is for part I, we have f of xy, which is x squared y e to the power y. To find f sub xx, f sub xy, f sub yx, f sub yy. For this one, we take both partial derivatives with respect to x. And for this one, we take the first partial derivative with respect to x and the second with respect to y. In this one, first with respect to y and second with respect to x. This both with respect to y. So if we are asked to find partial square root of f by partial x, partial y, which one do we take first? In this form, we take this one first and then this one. Okay, so if we have given this, we say we take the first partial derivative with respect to y and then the second with respect to x in this form. But if it's written in this form, we say we take first this one and second this. Let's find these four partial derivatives for that function, for the given function. It's easier to find f sub x and f sub y first. Let's find f sub x. F sub x equals to what? F sub x equals, here y e to the power y, that's a constant. That means its partial derivative with respect to x is only 2x times the constant parts. Okay, constant parts are y times e to the power y. Here we say it is 2x y e to the power y. This is f sub x. Okay, and f sub y equals, here we have two y functions, y and e to the power y. We say if we have f times g, its derivative is f times g prime plus g times f prime. Is it? And here we have the same. We have y times e to the power. We have y times e to the power y. So here we say y times derivative of e to the power y plus e to the power y times derivative of y. X squared is a constant here. We say x squared, then y times e to the power y, its derivative is itself. Okay, e to the power y, its derivative is itself. e to the power y plus e to the power y times derivative of the first one, which is 1. Derivative of y is 1. And equals x squared y e to the power y plus e to the power y. And you can also take e to the power as a common or leave like this. This is f sub x and f sub y. From f sub x, what can we find? We can find f sub xx and also f sub x y. We can find these two from f sub x. We take another derivative with respect to x for f sub x, and we get f sub xx. So what's the result? It is 2y e to the power y. Is it? This is constant. We just take derivative of x, which is 1. And it is 2 times y e to the power y. F sub xy. Then we take the partial derivative for the function for f sub x with respect to y. Okay? We take a derivative for the function 2x times y e to the power y with respect to y. 2x is a constant because we take the derivative with respect to y. It's 2x. And here you have y times e to the power y. The derivative of y times e to the power y is y ey plus ey. We found this before. Okay? So this is f sub xy. This is f sub xy. And from f sub y, what can you find? From f sub y, we can find f sub yy and f sub yx. Okay? What's f sub yy? We are going to take another derivative for this function for this one with respect to y. X squared is a constant. We'll just write down the same. Derivative of y e to the power y. We have multiplication of two functions. That equals first times derivative of the second plus second times derivative of the first. For this one, it becomes y ey plus ey. Okay, y ey plus ey. How about derivative of this ey? It's still ey.
Sir, is it okay if we end the class now because we have an event and we have our
Sorry. Okay, derivative of y e to the power y is equal to y ey plus ey, and derivative of e to the power y equals ey plus ey. Look, we found this and that one. If we just simplify it, we get x squared times y ey. Here we have ey plus ey, which is plus 2ey. And you can take ey as the common. We get x squared ey times y plus 1. This is f sub yy. How about f sub yx? This is f sub y. This one. This is f sub y. How about f sub yx? We just take derivative for that function with respect to x. Here, the bracket is constant. We just write down the same. I will take derivative of x squared. Derivative of x squared is 2x. So the result is 2x xex plus, sorry, xey plus ey. Ey plus. This is the bracket. We write down the same. We just took the derivative of x squared. Is that clear? First, it's easier to find first f sub x, then f sub y. After finding these two, you can find f sub xx, f sub xy from f sub x. Yeah. Yes. Look, this is f sub x. If we take derivative for this function with respect to x, what we get? Here, 2y ey is constant times x. What's the derivative of x? Yes, that's one. Okay, did you get? If we take the derivative of that function with respect to y, we get this. Look, 2x is a constant. And here, 2x is a constant. And derivative of y e to the power y is first times derivative of the second, plus second times derivative of the first. And we get y times derivative of ey is still ey, plus ey times derivative of y. Derivative of y is 1. So that's it. Okay. So it's enough for today.